Welcome to Topic 10 of Intro to Auditing. Recently, Whitworth University has claimed that 80% of their trees are pine trees. Your mission, should you choose to accept it, is to explain the details of sampling and test the validity of Whitworth's claim. As always, should you or any of your colleagues be discovered in your mission, the professor will disavow you and all of your actions. This recording will self-destruct in 5, 4, 3, 2...
John.
Fine. It won't self-destruct. You people are no fun at all.
Alright, let's get to work. The first step in sampling is to plan your test of controls, substantive tests, or both. In this case, we have decided to do substantive tests.
Okay, so now we need to define the deviation.
Yeah, and a deviation for audit sampling, a deviation is an observed result different from what you expected.
Yeah, you're right. And then for sampling, the auditor must define how this difference will be measured and what will serve as evidence of a deviation. Yeah.
Hey, yo, Ben, what do you expect out of this?
That's a great question, Eddie. Our expectation is that a majority of the trees in the loop will be pine trees, as can be seen in these. What our deviation might be is that in fact a majority of the trees are not pine trees, as can be seen in some of these trees that appear to be pine trees but are actually not pine trees. What are your expectations?
Our population is the entire tree population in the loop. Our sample unit is each tree in the loop. We numbered every tree in the loop, and then using our random number generator, came up with the 7 tree numbers that we're going to use. For example, this is tree number 12, and this is one of the numbers we'll be using.
Alright, so we'll be using Excel here to determine a randomly selected group of trees in order to use in our sample. That way we can be sure... What the heck?
Yeah, John, this is old school, man. No one uses that nowadays. So I got the latest technology. This is called the Generator 3.0. So what you do is gather all your data from the samples and you number them in these encrypted paperwork. You put it in here, like that, and you give it a little shake, and then you just retrieve, and it tells you what data you're going to use. So it says, this is encrypted, but I think it says number 12, so that's one of the samplings, and here are the rest.
So there are of course some inherent risks with using sampling as a method. One of these risks is basing our conclusion on the sample size. So we're taking 20% of 35 trees. So we're going to be testing 7 trees. Now, if we found any errors and we projected that onto the entire population, it might be inaccurate if we had any outliers. So that's the risk involved with using sampling as a method.
The purpose of sampling is it gives us an idea of the entire population without taking time to look at every individual population unit. So for our example, we have 35 trees in the loop at Whitworth, which would take way too long to look at every single tree to figure out if it's a pine tree or not. So we're going to sample 20% of those trees, which would be 7 trees. So here's our mock-up of the loop. We're going to randomly pull numbers and pick 7 trees to look at for our sample test.
In this case, we've devised 3 different tests to determine whether or not each of these trees are in fact pine trees. First of this is a taste test, the second is a smell test, and the third is going to be based on appearance. Here to give an example of this, Luke.
Smells like a pine tree. Tastes like a pine tree. Yeah, it looks like a pine tree. I think it's a pine tree.
Alright, this is another one of our sample trees, and taking a look at this, it does not smell like a pine tree. It does not taste like a pine tree, and it definitely doesn't look like a pine tree.
Yeah, why is it white?
I don't think this is a pine tree.
Okay, this is our next sample.
It sort of smells like a pine tree. Tastes a little bit like a pine tree.
Wait, there's something in it. Wait, taste it. What is this?
I don't think it's a pine tree.
Okay, so we gathered these samples. We have 7 of them. And from those 7, we concluded that we have a fake tree And the banana tree. Luke, can you do the math for me and see what we got?
Yeah, so 5 out of the 7 trees we had are real pine trees. That 5 divided by 7 is 71% of the trees of our sample size are pine trees.
So, based on the projections that we calculated, Whitworth's claim that 80% of its trees are pine trees turns out to actually be inaccurate. The last step in the sampling procedure is to document all of the various evidence that we've acquired.
The final step is to document the sampling procedures, which include the objective of the test and the assertions, population in the sampling unit, the definition of a deviation, the sampling technique, the list of deviations, an evaluation of the sample projected onto the population, and their overall conclusion.
Ready?